All right, Dr. Matthew J. Trom here. I had some questions about the electronics and motors lab about lab activity 4. So after you've done all of your PCB etching, you get down to this lab activity 4, which we did not talk about in class, but is an expected part of this submission. And what you're asked to do is each group should create a Wokwi simulation demonstrating control of either a stepper motor or a servo through some sort of external input. And by that, I mean a serial monitor, switches, push buttons, etc. And then under submissions, submission number 3 asks for a zip file showing your Wokwi motor control simulation. So what do I mean by that? Well, there is a browser-based platform, which is called Wokwi. So you can go to wokwi.com and up this will come. And this is a simulation environment that allows you to essentially wire components together, write code, and test that things work without having to physically build any hardware. So this is a great prototyping tool in the early stages of the development of your design projects to kind of figure out how the code works. So I'm going to click on Arduino, and as you can see, there's a bunch of featured projects, and there's a bunch of kind of other projects that people have created. This is like an open source environment, so you can kind of look to see what other people are doing. I would like you guys to start from scratch and build up a circuit for yourselves the way that you will do it for real when you're actually working with the real hardware, and get some practice doing that in this virtual environment. So I'm going to just click on Arduino Nano to show you how the environment works. So here's on the left-hand side, on the right-hand side, sorry, here's our simulated nano board with all the pins and the button that turns it on and off. And then over here on the left-hand side, this is my Arduino IDE sketch file. So this is the place where I write the code that drives the board. So what I want you guys to do is go into the add new part and add, let's say we need a motor. Yep, so here's a bipolar stepper motor. Bipolar because it has 2 coils. And then we're going to need a motor driver. Yep, so here's the right motor driver for that guy. And then we're going to need some sort of button or switch or something to control it. And so I'm just going to grab a push button, and that gets dropped there. So as you can see, I can basically, identify these components in this little plus add new part button, and then I can drop them in, and now I've got this simulated environment where I've got all these components. Now, really cool thing. There's no rhyme or reason to what I'm about to do, but just to sort of give you a demonstration, each one of these pins, I can actually click on this pin, and that creates this wire, and I can move the wire over to my motor driver, and I can actually connect the pins of my stepper to the control pins of my motor driver, right? And I can take my button and I can connect that to the pins of my Arduino board and so forth. So, no rhyme or reason to this. I'm just sort of simulating it, but you get a sense of you can actually simulate the wiring of your components in this environment without having to worry about like doing it physically on a breadboard. So that's really cool and powerful as kind of a practice tool. And then over here, you can write the code that controls the Arduino board that facilitates the function of all these things. And so here's what I want you to do is to put together components like this and write a code that does something interesting, and then save it and upload that zip file to Canvas, and I will take a look at it, and that will demonstrate to me that you guys have gone through this process and you know how to use Wokwi to simulate all the electronic components that you guys will need to build your projects. To just sort of give you a sense of what this could look like, this is one that I created. So let's see if I can zoom in here a little bit. Okay, so there we go. Okay, so I've got a stepper motor, a motor driver, my Arduino Nano, and then I've got 2 buttons. And I will say that I went out into the internet and I basically took this as a template. And then I rewired it because it had all the components I needed. I rewired it and I recoded it to do what I wanted it to do. So I would like you guys to like build these up from scratch, but if you get stuck, you can, go out into the internet and you can search for other people's simulations, and you can use that kind of as a starting template. But I would appreciate it if you didn't just submit somebody else's work as your own, if you actually modified it in some way, because that's really the point of this exercise, is to build up some experience and skills with one, how to do the wiring in this virtual environment, and then also how to do the coding and to use this platform to basically check that your coding works the way that you expect it to. So you can do this without any hardware, right? So whoever is your coding guru in your team, you can start on this immediately to start to kind of figure out how you're going to drive your motors in your designs. Um, so what does this thing do? Well, I am setting the various pins, right? So I'm defining my step pin, my direction pin, and then my forward button and my reverse button. So those are all assigned to pins on my board so that I can read them. I've got a Boolean variable here that's just trying to determine whether the stepper motor is turning clockwise or counterclockwise. I'm declaring my pins. So my step pin and my direction pin are both outputs. Um, I also need two inputs. And remember in class, we talked about noise being, kind of the killer of digital devices. So notice that I'm declaring these two pins as input pull-up pins. Remember when you use the pull-up feature, there's an internal pull-up resistor in the Arduino board, and that will enable the pull-up resistor, which is basically a way of mitigating noise. So I'm intentionally declaring these guys as inputs attached to a pull-up resistor. And then here, I'm just reading first the green button, whether it's pressed or not, and the red button, whether it's pressed or not. And if it is, then that changes the value of this variable is clockwise from true to false, depending on which of those buttons I push. And then here, I'm just sending a low signal, a zero signal to step pin to basically initialize the step pin at 0. And then I'm checking to see whether I've pushed the button for clockwise or pushed the button for counterclockwise. And depending on which button I pushed, I go to a subroutine here. This is the uh, clockwise subroutine, and all that does is it sets the direction pin to high, which is clockwise, and then it sends a step command, a high signal to the step pin, and then I just wait for 0.05 seconds, 50 milliseconds. And then I go back up here and I check again to see whether I push the button, and this just cycles. And then the only thing that's different about this subroutine, which is for the other button, is instead of the direction pin being high, the direction pin is low, which means it's going to turn counterclockwise instead of clockwise. And the other thing that's different here is that the delay is 10 milliseconds instead of 50 milliseconds. And so it'll turn faster in the counterclockwise direction than it'll turn in the clockwise direction. So that's what this code does. I do want to show you one thing. So I'm going to make a little change here. I'm just going to add just kind of a dummy variable there and remove it. So the first time you write your code and you hit the start simulation button, you'll have to compile. Oop, except my change wasn't big enough. Here, let's try again. Just going to add like that, and it's going to throw an error at me, right? But you can see it's compiling, and sometimes this takes about 10 or 15 seconds, and I'm sure it's going to throw an error. Yep, because I messed up that code. So let's close this. Let's get rid of that A button, or that A that shouldn't be there, and then we'll okay, there we go. It didn't even need to compile it because this just reverted back to an old version. But I did want to show you the compile feature and the error feature so that you didn't get worried if all of a sudden that happened. It sometimes does need to compile. It takes a little while. Okay, so now this is running, and it's doing it, exactly what I described. So the stepper motor is turning clockwise, and it's turning, kind of slow. And I'm going to come along here. I'm going to say, okay, I want to change the direction. So I'm going to use my mouse. I'm going to hover over the button here, and I'm going to push the button. And you can see what happens when I do that is the stepper motor starts turning in the counterclockwise direction, and it's turning 5 times faster than it was turning before. So I can go back and I can click the green button, and you can see now it's slow turning clockwise. And I can click the red button and it's faster turning counterclockwise. And that's essentially all this code does is controls the stepper motor using these buttons to determine a direction and a speed. And that's really all I want you guys to do is just to put something together that's very simple to just illustrate that you know how to use this tool to simulate how to drive a stepper motor or a servo using an Arduino board, and then having some sort of external input that changes the way that the motor functions. That's really all I'm after. Okay, so hopefully that was clear. What I want you to actually submit is a zip file. So how do you get to the zip file? Well, you can go to this downward arrow and there's an option to save, lock, or download zip project. So we'll go to download zip project and you can see I've done it a couple times. But yeah, oh, there it is. Okay, I called it copy because I saved it a couple times, right? So there's the zip file. And so all I want you to do is just take this zip file and put it into Canvas. And, this is kind of fun, right? You're just sort of playing around a little bit. So I'm going to open all of them and just kind of play with them and see how they work and see what you came up with. It's kind of a cool, fun little project. And that's it. That's all that's required for lab activity 4 and this submission. So hopefully that clears up any questions or problems. And if you have any more questions, feel free to ask me in Teams or in class. Thanks for your time and attention. And I hope you guys have a little fun with this because it's just a fun little project to kind of build up your skill set. So thanks.